Hi all, welcome to our third lesson in our functions unit. Today's lesson is on operations. Our essential question is, what is a composition of functions and how is it found? So we're going to start talking about a new operation, which is a composition today. So we're going to do some old stuff today. Our first problem is given f of x equals x squared plus 5x minus 1 and g of x equals x plus 1. Find the sum, the difference, the product, and the quotient of the two functions. So remember, sum is the answer to an addition problem. Difference is the answer to a subtraction problem. Product is the answer to a multiplication problem, and quotient is the answer to a division problem. So these are all ones that we've done before. We're just going to review them really quickly, make sure that everyone's good with doing it, and how the new notation is with two different functions and how we're going to do it. So we're going to go ahead and start with number A. So I'm going to start this way. I can actually do this problem two different ways. I could take f and g and add them together first and then plug in -2 and get my answer. Or I can do them individually. I can say f of -2 equals -2 squared plus 5 times -2 minus 1 equals 4 times -10. Oh, not -10, sorry. Let me fix that. Not times, I mean. 4 minus 10 minus 1, which equals -7. And then I can find g of -2, which is -2 plus 1, which equals -1. And then I'm going to put them together. I'm going to say f plus g of -2, which is going to be -7 plus -1, which equals -8. Done. Okay, not too bad, right? And I find it, for me, I find it easier if I just do them individually and then add my answers together, or do them individually and subtract my answers, or multiply my answers, or divide my answers. I just find it a little easier to do it that way. If you want to go ahead and add your functions, or multiply your functions, or subtract your functions first, and then plug in your value, and you find that easier, that's awesome. Everybody thinks differently, so it might be easier for you to do it that way. And I am totally and completely awesome if that's the way it works for you guys. So here we go. We're going to add, this one says f plus g of x. So great. So I'm going to do f of x is x squared plus 5x minus 1. And g of x is x plus 1, and then they want f plus g of x is going to equal x squared plus 5x minus 1 plus x plus 1. So that is going to equal, am I going to run out of room today? Let's see, x squared plus 6x. I'm not going to run out of room. Now, I just want to kind of prove to you that I'm going to get the same answer. If I plug -2 into here, I should, right, this says f plus g and this says f plus g, and I added my functions together. So if I take -2 and plug it into this function I just got, f plus g of x, which is x squared plus 6x, and I plug -2 in wherever there's an x, I should get -8. So let's try it. So I get -2 squared plus 6 times -2, which equals 4 minus 12, which equals -8. So either way you do it, I don't care. Whichever way you feel that your brain works better or you understand better, awesome. Okay, so next problem says g minus f of x. So g of x equals x plus 1, and f of x equals x squared plus 5x minus 1. And then they want g minus f. Let's see if I can write. I think I did this wrong when I was writing it out also. Parenthesis g minus f of x equals x plus 1 minus x squared plus 5x minus 1. So that's going to give me x plus 1 minus x squared minus 5x plus 1. So that equals negative x squared, like terms here and here, minus 4x plus 2. Awesome. Okay, now this one says f times g of 6. So I'm going to find f of 6 first, which gives me 6 squared plus 3, oh, that's not a 3, whew, plus 5 times 6 minus 1, which is 36 plus 30 minus 1, equals 65. And then g of 6 is going to equal, let's see, that's 6 plus 1, which equals 7. So f times g of x is going to equal, since I did my math wrong last time, I have to fix this, 65 times 7. So that's 65 times 7 equals 455. Nice. Okay, and then one more problem. So we've got f of x again. Again, f of x is x squared plus 5x minus 1. And g of x is going to equal x plus 1. So f over g of x is going to equal x squared plus 5x minus 1 divided by x plus 1. Now, if I could factor the top, if I could simplify this, I will. But since I can't factor the top, I'm done. Later this year, we're actually going to learn how to divide this. But we don't know how to do that yet. So if I cannot simplify it, we're done. Okay? Awesome. So we're moving on to the next section here. And we have a little definition of what a function composition is. So function composition is applying, let me get a pen here, applying one function to the results of another. Okay, so I put a number into f, I get that, and I put it into g. Okay, so that's what a function composition is. So the results of f is sent through g. Okay, and it's written g, I'm going to write it wrong, parenthesis g of f of x. Okay, so I get my thing, I put it through f, and then it goes through g. Or I can write it like this, g of f of x. So either way is correct. Okay? Awesome, you guys. So now we're going to practice it so you can see what we're supposed to be done. And as you can see, we've used both notations for these problems, both types of notations, so you can get used to it. But in the future, or even maybe later today, hint, hint, as we're working through class, you'll see either one or the other. So you need to know how they work. So this one says, let me get a highlighter here. This one says I'm going to take f of 1 first. I'm going to do f of 1 first, and then I'm going to get that result, and I'm going to put that result into g. And this one says the same thing in a different way. I'm going to take take 1, and I'm going to put it into my closest letter, which is f. So I'm going to find f of 1. And then I'm going to get that whole answer and put it into g. So I'm going to get this whole answer and put it into g. And so that's what my my notation is saying. So let's go ahead and do the first one, part A. So I'm going to find f of 1. Okay, so that would be 1 plus 9, which is 10. Now I'm going to take that 10 and I'm going to substitute. Where it says f of 1, I'm going to take that f of 1 out and substitute in the value for f of 1, which equals 10. So I can remember, I can take, when I'm substituting, I take something out and put something of equal value in. So g of 10. So f of 1 gets replaced with 10 because it's equal value. And then I have 10 plus 4, which equals 14. And that's my answer, 14. Okay, let's try this again at B. So the first thing I'm going to find is g of 2 right there, g of 2. So g of 2. So that's 2 plus 4, which is 6. And then I'm going to find f of 6. Okay? I'm going to replace that g of 2 with a 6. So that would be 6 plus 9, which is 15. Okay. I'm going to go again. I'm going to find g of 3, g of 3. So g of 3. 3 plus 4 equals 7. And then I'm going to take that answer and substitute it in for g of 3. So I get f of 7 equals 7 plus 9, which is 16. Okay, so now on to D. It says find g of x, g of x. So g of x equals x plus 4. And then I'm going to substitute that in, so I'm going to find f of x plus 4. Whew, lost my pen. So I get x plus 4 plus 9, right? X plus 9, but x is now x plus 4, which equals x plus 13. Done. Now this one's interesting. It says g of x. So I'm going to find g of x first. So g of x, as we know already, is x plus 4. Now I want to find g of x plus 4. So I get x plus 4 plus 4, which is going to equal x plus 8. Okay, so if you have any questions, make sure you're asking in class so we can clarify, or you're sending me a message, but we will go over more of these in class. Thank you guys. Have a great day. See you next time. Bye.